Welcome to this trig video on identities for grade 11.
Identities is the fourth of our 6 trig concepts. If you started at the beginning of the trig series, you're making good progress. Well done. These identity questions can feel very tricky, and so we encourage an active process of what to look out for as you work through them. We will have a look first at a list of suggestions of what you may find, and then together we will look through 2 worked examples. So here is our list. It is quite long, but all necessary, so remember to take notes as you listen. The first on the list is to use the right-hand side to guide you. Things like noticing if the right-hand side is a fraction, or if it is 1 or 2 terms, or which ratios it contains, etc. The next is to be on the lookout for the formal identities, the tan identity as well as the squared identity. Remember all the different ways the squared identity can show up, and also that applying the squared identity is often used to cancel out a 1. Remember also that a 1 can be replaced with sine squared theta plus cos squared theta, often to create a trinomial. The presence of a sine theta cos theta term can be a clue for this option. Next, if there are terms, then look to factorize. Then you may need to add fractions or split terms, depending on the other side. Remember always to be on the lookout for like terms. You don't want to miss these. And then there is the trick of multiplying through by a particular factor that creates the opportunity to then apply the squared identity. We illustrate this option in one of the worked examples to follow. So I know this list is quite long, and you may be wondering if you need to learn it. A suggestion is to write it out and keep it next to you as you do a couple of examples. Hopefully then it will become a way of thinking when doing these questions rather than a list you have to memorize. Okay, so hopefully you feel ready to try an example. We've included the reminders of what to look out for as you work through this question, so pause here and give this a go. Let's have a look now through the solution together. On quick analysis, we see that both the left-hand side and right-hand side are one term. The left is in terms of sines and coses, and the right in terms of tan. Now, if we look more closely at the left, the fraction consists of one term in the numerator with 2 factors, and 3 terms in the denominator with a couple of squared terms. Let's look to see what we can do here. When we look to apply formal identities, remember all the different ways the squared identity can appear. Be careful not to be tempted to see sine squared plus cos squared here and think 1, as this is actually minus sine squared plus cos squared. What we do have, though, is 1 minus sine squared x, which we can replace with cos squared x. You may need to get used to going with your ideas one step at a time and not necessarily knowing how it's all going to unfold. I often say think with your ink, meaning write things down as you think of options to try rather than imagining in your head how they may work out. In this case, as we write in cos squared x, we see there are now like terms in the denominator. Adding these gives us a clearer picture of heading towards the right-hand side. Simplify by cancelling cos x, and you are left with sin x over 2 cos x. Sin over cos is tan, and so we can write this as a half tan x, which is the right-hand side. Let's go straight into the next question. This question looks quite different, so let's see what thinking comes up for you. Again, the steps are here to support your thinking process. We encourage you to be active in looking for options rather than hoping for something to jump out. Pause here to give yourself a moment now to try this question. Let's start with the left-hand side. Did you notice that there was a tan on the left, but that the right-hand side was all in terms of sine? This is a clue to use the tan identity. You now have both fractions with a denominator cos x, which means we can add the fractions easily. Now, because the whole fraction is being squared and there's not much we can do inside the bracket, in this next step, write it a little differently by applying the square to the numerator and denominator. We now have the numerator in terms of sign, so getting closer here to the right-hand side, but the denominator is in terms of cos. Is there any way we can change this? Let's see if our squared identity can help. Remember all the ways it can be written, and yes, here we can see that cos squared can be replaced with 1 minus sine squared. So it definitely feels like we're getting closer now, but we're not quite there yet. Guided by the right-hand side, write the numerator out in full rather than expand the brackets. And in the denominator, did you remember that this is a difference of 2 squares? We can now see that these cancel, and we are left with 1 plus sin x over 1 minus sin x, which is the right-hand side. The other option for solving this question is to work from both the left-hand side and the right-hand side separately and see if you can get them each to a point where they are equal. We've used a useful technique here, which is a good trick to have up your sleeve, and that is to multiply by a factor that creates the potential for a squared identity. In this case, we didn't need to take this further as the two sides were equal at this point. But can you see that the denominator could then have been changed to cos squared x if necessary, depending on the need of the question? Once you feel comfortable with the theory of the concepts covered in this video, then pop into our study guide to try some examples. Applying theory as soon as possible gives it the best chance of settling and becoming knowledge you feel confident about.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.